My name is Rahel, and then welcome to Behind the Lab Coat. Kindly introduce yourself to us, and then we go ahead with a few questions.
Right, I'm Michael watching reading Biomedical Science final year.
Oh, okay.
Yeah, and it's very interesting. I love communicating too, so I think I'm not at the wrong place.
Okay, so Michael Boakye is reading biomedical science, and then he's a final year student.
Sure.
How interesting. So, can you tell us a little about biomedical sciences? It's not mostly known by people, and even if people know about it, they don't know what really entails. So, tell us a little about biomedical science.
Right, when I got a chance to come to UCC, along the line, I was like, oh, what is this? But getting to the final year, I got to know that it exposes you to so many disciplines in the sciences where you take a lot of courses. If as far as UCC biomedical science is concerned, and you have the opportunity to study a lot of areas in the sciences, and mostly it channels down to research. So you will be exposed to the physiology, the anatomy, the psychology, the entrepreneurship, a whole lot of them, so that at the end of the day you choose the area you want to specialize. Yeah, so that's what I can say about biomedical science. It's basically into research.
Okay, so biomedical science is basically into research, but then it exposes you. So let's look at some of the exposure. You spoke about the course content, and then the course content you're mentioning a whole lot. So if I may ask, how is it structured? Is it packed? Is it flexible? Is it the one that you can equally pick what you desire? How is it like? Just tell us about the course content.
Flexibility of it is, I would say, subjective.
Okay.
Yes, each and everyone has a way of coping with things. So I think that it is a bit flexible, and the line is a bit flexible.
a bit.
Yeah, sure. And you have the opportunity to, the way it is structured, you have the opportunity to move gradually.
Okay.
So like the first year, you'll be exposed to the basic sciences. That is what you had from the secondary school, like the chemistry, the physics, the elective math and stuff, so that you'll be able to record the things you've done so far. And then going to the second year, that's where you move into the biomedical science proper. That is where you're being introduced to the basics of biomedical science. We're going to do the anatomy, the physiology, and not to forget, it is a health aspect too. So be exposed to the anatomy, the physiology, the cell biology, and these ones they are also the basics for you to know as far as biomedical science is concerned. So the structure, I think that it is okay, but it goes to a lot of hard work. Sure.
Biomedical science entails a lot, and then the course content is really structured as far as biomedical science is concerned in UCC. But then it goes with a lot of hard work. So with the hard work, is it that you face some challenges as a student? Just tell us.
If I'm to be honest, I think first year it was cool. As a science student coming from the senior high school, it's very cool. You come, you repeat your organic chemistry, your inorganic chemistries, you come with your physics and stuff. You find that it's so easy. But when we just negotiated the curve into the continuing one, that is level 200 second year, where we're introduced into the anatomy and stuff, and I was like, oh, this one should be normal. But there it came in that it's something different. Though it's a bit up, but it's different because this time you need more of analytic and then the cognitive to function well. Because something like anatomy, you can't read anatomy like you read your chemistry. No, you can't read like that. You can't read anatomy like you read your physics. So I think that the basics that is continue from SHS or senior high school to the continuing into the department is a bit of sharp curve. So I was a bit I was a bit dizzy. I wasn't able to see things well. So I kind of consult friends, consult lecturers, TAs, so that I can find my feet. It was a sharp curve that I don't think it's only me. Most people were we're falling apart.
Okay,
Yeah,
so
sure.
right from the SHS, you can just say that from for the first year, just recalling from the SHS. But then as you start the program itself in level 200, you realize everything changes, and then you need a different approach.
Sure.
Okay, so his approach towards the hard work was consulting friends, TAs, and then everyone who can make it possible for him to find his feet. Interesting. So you talked about exposure. So the exposure, you are now telling me you're in level 400.
Sure.
And what has biomedical science from level 200, level 300, as well as level 100 led you into level 400?
Okay, I would say, see, growing up, many science students would say that I want to become a doctor, I want to be an engineer, I want to be this, I want to be that.
Okay.
So, biomedical science, I was like, okay, maybe after this, maybe I would just turn around and then maybe go back to my medical school. I would enjoy it. But going on, I could see that there are a lot of aspects of the sciences that we are not exposed to from tertiary, that are from the secondary school, that I'm even praying that one day I would have the opportunity to set up something, a group of people that will go back to the secondary school and expose them very well to what the university entails, not just coming to be doctor, no, there are so many things. So I think that it has really helped me to know that there are so many aspects in sciences that relate in relation to health that I can also venture into. It can be into my favorite, cancer biology. You can just doing research into cancer. We have a lot of things going on in cancer that people are dying. Now this time people are looking into the metastases, others are looking at the mechanisms, others are looking at pharmacology, that is the drug aspect, how to treat them. There are so many uncountable areas. You can go into the biotechnology, you can go into the pharmacology aspect where you'll be developing drugs. There's so many, the psychology, like so many things, so many areas that biomedical science will expose you to. The one I'll never forget is pharmacognosy, which is exposed to herbal medicine. So you can also move into that area too. Whilst people are now we are in the era of natural products.
Yes.
So I think we have what they call this food people, Herbalife. Yes, we have Qua FS. They are all dealing with natural products.
Okay.
So this time, I think it's also another opportunity to venture into these areas where a lot of researches are also being done. So biomedical science has really exposed me to a lot of areas.
Okay, sure. So biomedical science is the topic on board now, and then it's a research-based program.
Sure.
And as a matter of that, it exposes you to a lot of research areas in the sciences. Sure. We shouldn't only prioritize some programs such as the medical doctor and then others that you can think of. Okay, fine, you can prioritize it though, but then per what he's saying, meaning the job market would be limited, or people will be more than necessary as they need in that sector. So you made mention of cancer biology, which is your favorite. If I should ask, as a final year student, I'm sure you're taking a project, right?
Sure.
So can we see or can we hear about your project area?
Right. Having an interest in cancer biology, my project is channeled to cancer. So what I'm doing now is that I'm dealing with liver cancer, where we would induce the animal model, that is rats, with CCL4, and this CCL4 is a chemical that would cause the inflammation in the animal in the liver, so that it will develop the cancer. And we are using citrus pills to cure or to treat these cancers. So not long ago we had our pills dried, and we're about to powder it and extract the flavonoids in them. So from pharmacognosy, we were taught that there are a lot of flavonoids in the plants, secondary metabolites, and one is flavonoids. And research shows that these flavonoids, they are anti-cancer drugs, or they can help treat cancer. So we are trying to prove to see if that is the case. So that's what we are doing. So basically, we are on it. We are waiting that maybe we get it powdered and extracted.
So if I'm to understand you clearly from what you said right now, meaning the courses are related, because you made mention of you studying pharmacognosy in level 200, and then now you're taking a project in level 400, but then you're applying it in your research work, which is cancer biology, specifically liver cancer. So you are using the drug aspect, which is the traditional drug, and then you are transferring the knowledge you acquired there to go ahead with your research work. But then you said you are using rats, and then you are using CCL4. Okay, let me talk about the rats first. Why is it that you are dealing with cancer biology, and we know that cancer is existing in humans, but then you are using a rat? So as a researcher, what drove you to use a rat for the research, but not a human being?
That's interesting.
Yes.
In the sciences, you just can't take human being and work on human being direct. I think previously, I'm not too sure, but I'm thinking that maybe they attempted to do something of that sort. But for ethical rights, you can't use human being. The person can die. So even the rats we are using, we have regulations that govern these rats. You just can't use them anyhow. No, you just can't use them anyhow. So even with them, we are so much careful about what we do to them. So the issue is that research has proved that these rats or the mouse, they have their model, it's related to that of man. So whatever we do to it in some way can be transferred into human. So after these things, we have something called clinical trial. We take this one to trial to see how it's the potency and the efficacy of these things in humans before we continue with that. So for instance, in the pharmacognosy and the pharmacology, we have what we call the lethal dose and then the effective dose. So if you try the effective dose in the rats or the rodents, that would also give you the guarantee to try it in human too. So if you try in human and you experience that it is working, that's what we call a clinical trial. You don't take a lot of people. So even I think we should also know that before drugs are being approved and being sold out there, it goes through a lot of processes, a lot of steps. You have to take through clinical trials, a lot of them, before it is approved. So the issue here is that the rat or the rat has a model that looks like that of man. So you can use that and transfer that same knowledge back into man.
So the researchers are telling us that you can't go ahead and then just start working on human beings as far as research is concerned. You rather use the lab rat, and then the lab rat is equally correlated to human beings. So when everything works hand in hand, that's when you can equally try on human beings. Interesting. I'm getting really exposed. And you made mention of you not knowing what actually goes on in the tertiary when you were coming to school, but then you would wish you go back to the researchers schools and then you tell them, as far as you have opportunity on this platform, I wish you tell them something which will motivate them to enter into other branches of science rather than seeing other aspects.
Right. Thank you. I think one thing is that the society we live in has put, let me say, they have prioritized some let me say, profession than others. For instance, should it be that a student, let's say in the senior high school, goes home and then tell the parents that, let me say, I want to be an artist, I want to draw. Oh, come on. Be a medical doctor, do that, do this. But they don't also know that these people also have their space in the market. They have their space. So you shouldn't only, particularly to science students, shouldn't only focus on being a medical doctor, being an engineer, being being a nurse. These are the three things people, most of science students, they focus on. But I want to assure them that they can equally do some things which are equally important as being a medical doctor. For instance, before a medical doctor would be able to diagnose properly and prescribe a drug for a patient, he has to consult the laboratory technician. He has to go to the laboratory and run tests to prove what he's saying. So should it be that there is no laboratory technician? In the same vein, we have radiographers and sonographers. They also take the CT scan, the MRI to also bring out to see or to confirm that indeed the diagnosis of the medical practitioner is right. So there are a lot of areas that it can enter into. For instance, now I think I was reading one day and I realized that there are some bioinformatics where they deal with data science. See, when you go to laboratory and then we are working, we usually work. We have what we call the wet lab, where you do everything in test tubes. But now we also have dry labs where you do everything in computers.
Okay.
So these people also carry the information into the computer to give a pre-informed result of what you'd have if you're doing the wet lab laboratory work. So it means that there are a lot of space out there, that our students in the secondary institutions should be exposed to these things, so that it will even motivate them. Saying that if you don't get 6 A's and 8 A's, you can't read medicine. But let me tell you, you're 14, you're 18, your B's, your C's, you can equally put them together and read a course or a program that will also take you out there, provided you are serious.
Okay.
Provided you are serious. So I think there should be a lot to be done, and then I would also plead that if you can get the opportunity, you can also, or if you can add up to what you're doing, it'll be something so nice that
interesting.
it'll
So
help.
the researchers bringing terminologies on board, the wet lab and the dry lab. So the wet lab is what is actually visible, but then the dry lab, we are actually translating science language into computer language. It's interesting. Okay, as a researcher, and then I should say, with whatever I've learned from you right now, you serve as the building block in healthcare profession.
Exactly.
So as a researcher, that you are serving as the building block in healthcare profession, by 2030, we are aiming at quality healthcare as part of the SDGs. So with that, what can you do? What can you say? Which impacts will you have for that goal to be accomplished?
Right. Considering the state of the nation, for instance, the state of the nation now,
Okay.
I think that there should be a lot of research works.
Okay.
Because there are so many things. Do you know that even before people go to the hospital, many times the issues they have, these issues have gotten to the areas even beyond control.
Okay.
So I think that if research is being done very well, they can be informed about some of these things so that they would even know basic things concerning their health.
Okay.
So that they will not be like be in a world where they don't even know what is going on with their system or what is even happening to them. So I think that what I can do is to do more research into some of the areas and things happening, so that it will be easy for the people in my country particularly to be able to address themselves with things happening, and also to know the diseases happening, how they can also manage themselves from these things. So I think if things do not change in my country, it will be very difficult. So I think that if the government could, it should be able to create more avenues and give a lot of opportunities in those who are also into these aspects, not only to the medical field, but those who are into research, those who are into the sciences. For instance, we have agricultural science that people don't pay attention to, but it's doing a lot of work, a great work, because you are what you eat.
Interesting.
So if you want to improve on the standard of living and then people's health and to achieve this SDG, I think a lot of things should be done.
Okay.
A lot of
So
things.
biomedical science opening a lot of research works to attain a lot of discoveries. So now biomedical science is all about research, and then research work is opening avenues for a lot of discoveries. Let's take it from there. Another SDG is gender equality. So right now that you are trying to tell everyone that there are a lot of opportunities out there once you study biomedical science, there are a lot of discoveries. How are we balancing the female aspect with regards to the male, because right now we are seeing science to be, or the mentality we have currently is science is a tough program. Science is a tough program. So we should just channel it through the males, not rather the females. So how is gender equality within the study of this program?
I think now it's not. I thank God now that we find a lot of women in academia.
Okay.
Because previously it was men, and personally I advocate a lot concerning women. Not that I'm a feminist, no, but I see that if we are to give women opportunity and motivate them to come up there, it will create a lot of serene environments, and it's also going to help in so many things that we think only men can do. I'm not saying that men are not able. They are competent, they are able. But have you also thought of having women in these areas too? What would happen? So I'm seeing it in a way that we should motivate our girls, motivate them, we should help them, and so that they will change their mindset. Sometimes they also see themselves not being able to do it.
Okay.
But let me tell you that it is possible that women can do it. Okay. So one thing we can do here is that we need to motivate them, we need to give them some of the things they need, so there will be equity.
Okay.
So there will be equity for both men and women to be up there. And personally, I see that if that happens, the world is going to be a fine place to live. A fine place to live. Fine place to live.
Interesting. So we are attaining a very good proportion with regards to the male and then the female gender as far as biomedical science, which is mainly a research work, is concerned. And then once again, don't forget that biomedical science opens up to a lot of avenues, which helps in attaining a lot of discoveries. Once again, Mr. Michael Boakye, we are so much privileged to have you here, and thank you so much for your time. We wish to have you here once again. Thank you so much.
Welcome. Thank you too.
Yes.